let's talk about today the reinforcement learning. See, in reinforcement learning, what happens is a type of machine learning where an agent means our model, learns to make decisions by interacting with an environment in order to maximize cumulative reward. Unlike supervised learning, where the model is trained on a fixed data set. So there is no fixed data set here. Your machine learning keeps on going and keep on learning. So reinforcement learning is based on the idea of learning through trial and error, with the agent improving its performance. So first of all, let me show you reinforcement learning from GIF animation. See, it learns by its experience of reward. Okay. All right, I will show you the animation. So basically, it is like learning through experience. So how many elements we have here? Like agents, you can say, learner or decision maker that interacts with the environment. So suppose you must be having, one kind of, you can say, car. Yes, one kind of car which interacts with the environment. You can say that we have the road. Okay, so the learner or decision maker interact with the environment. The agent's goal is to learn a policy that maximize the total reward over time. It has to learn. It has to take a lot of maximize the reward. So maybe if you say if this goes out of this across the path, he will go -2. But if he will keep on continuing this path, he will get +2 every time. So what is environment? The external system with which the agent interacts. The environment provides feedback to the agent in the form of reward. So environment will give the feedback. So this road is, you can say, environment. Okay. So as we go down, yeah, as we go down, so we'll see some more things like state, a representation of the current situation or configuration of the environment. The agents observe the state at which time step and use it to decide the next action. So basically, it is state is within the this agent, we can say, which decides like which of the next step it has to take, whether it have to keep going to the state which will get it 2 points, or either it has to move outside. So that is the state. Like we can say it's a deciding factor to decide which option to take. Okay, then we have, okay, so we can say then we have action. This the set of all possible moves or decision the agents can make. So agent can go straight, it can go here also, it can go out of the road. So these are all the states we have, three states we have. The agent selects an action at each time step based on the current state. So whatever the current state is, so it will decide according to that. Just 1 minute. Okay, what is reward? If we talk about the reward, you can say, mm, yeah, reward is like the points which it will get. A scalar feedback signal received by the agent after taking the action. So it can take multiple action and it will get the reward. Okay, the reward indicates the immediate benefit or cost action according to the cost action taken. So the goal is to maximize this reward. Fine. Okay. So we have some advanced things also like a policy, value action. We'll go through this also. So what is policy? A mapping from state to actions, states to action. The policy determines the agent's behavior, specifying the action to take in each step. So you can say it's like a function, okay? Like on what kind of act, what kind of a state, what actions to be taken. This is kind of a, you can say, function. Policy can be deterministic or stochastic. So that goes according to the graph also, we can say, like whatever the action is performing good, we are this will be taking that action. Okay. Values function. A function that determines the expected cumulative reward, also called a return, from a given state. Given state as following a particular policy. The value function helps the agent evaluate the desirability of being in a particular state. So it the value function is it also knows that after if it is taking the straight road, what reward it will get. If it is taking the off road, what reward it will be getting. So it also knows that. So that helps to optimize and maximize the reward. So we can say that. So this is the Amazon car. They made it. If it is going straight, it will always get the two. We can say it will always get the two reward. But it is if it is going a little bit, at this side, so the rewards will decrease. It will be only 0.2. But if it is going this on this purple road, it will not get anything, right? So let's see how this our function learns from it. See, our model is learning. Suppose I ran the car in the beginning and it gone through, you can say it gone through, just wait. Yeah. Suppose it gone through off road like this. So you can see that after the first iteration, it just got um, very little amount of reward, right? This is a reward and versus iteration graph. So this car is getting very less reward. Then again, we did one with more iteration. You can see that the car is now not moving towards the this purple line. It just be on this line and trying to reach at the end. So you can see there is a little bit improvement in the reward, right? So as we perform this iteration many times, 5, 10, 15, 20, 25, you can see the rewards is getting improved, right? If you see the blue one, it is now improved from, now it is improving until like minus 200, right? Okay. Again, if you start your car making learn, so you'll see that from the beginning it will be starting from this minus 1000. So as you start the iteration many times, it will keep on maximizing the record, right? At the end, you will receive this red one, which is the most optimized way in the rewards. So this is how the graphs tell us that how our model learns. Okay, so it will take a lot of iteration, like trial and errors. Ultimately, it will start reaching through this. Okay, So this is reinforcement learning. Okay. Q function, action value function. What at action and value function? Okay. The action value function that estimates the expected cumulative rewards from taking a action A. The car can move anywhere. Action it can take is like it can go off road or straight or little bit diagonal. A given state as then the following the particular policy. The Q function is central to many RL algorithms such as Q learning. So basically, it is a relation between the what you can say what action it will be taking, the function that estimates the expected cumulative reward from taking specific action. So what reward it will get. So this function knows and it will try to improve it. Exploration versus exploitation, you can say. Okay, this is the approach on which the reinforcement learning works. Exploration means trying each and every path, involves trying out new actions to discover their effects and potential reward. What is exploitation? Like involves selecting action that the agent already knows to yield high rewards. Balancing the exploitation and exploitation in key to is a key challenge of RL. So with the help of both, it will make a balance and it will find a optimum path. Okay. So we have many types of reinforcement learning like model free RL, model based RL. So Q learning, SARSA, DQ networks. These are the examples of model free, and model based are, we can say, a agent build a model of the environment and uses it to plan and predict the outcome. The approach can be more sample efficient but may require more computational resources. There is not such model here. Uh, the agent builds model on the environment. So it keep on going to the model and it keep on making the patterns. So this is how it works. Popular algorithm in machine reinforcement learning like Q learning, SARSA, deep Q network, where various you can say algorithms we have here. Okay, so what is the application of like real world use of this reinforcement learning? So it is used in robotics, you can say. Autonomous robot use RL to learn tasks such as walking, grasping, and navigation. Game playing. So RL has been used to create an agent that can play games like chess, Go, video games at superhuman level. In finance, RL is applied in algorithmic trading like in stocks to optimize the investment strategies. In healthcare, personalized treatment plans and resource allocation, recommender system, dynamic recommendation model that learns user preference over time. So can anybody give me example of this one? Healthcare. In healthcare, where have you seen this reinforcement learning models or robots in healthcare? Write down in the chat. Okay. Surgery. Wow, nice. Diabetes and heart prediction. No, see, prediction is related to the, that is machine learning. Prediction and all these things. Surgery, yes, surgery you can say, like robot. You can say like some robots which, you know, do the stitching. That can also be reinforcement learning. Reinforcement learning in healthcare. Okay, let me see here. Mm, digital doctor. Any more example? Drug development. Okay, that is fine. Okay, let me try some more things. I'm telling you. You people have the Google, try it. Yeah, some is drug discovery, hospital resource management like optimizing bed allocation, staff scheduling, And patient monitoring, yes, this is also developing early warning system for the critical event such as cardiac arrest, epidemic control. Yes, a lot of departments, or you can say lot of equipments we have where we can use this. See, basically reinforcement learning is all about, trial and testing model. So like you can try it on anything. Basically, it's like a baby which just started learning thing. So okay. Reinforcement learning is a powerful approach to machine learning where an agent learns to make decisions by interacting with an environment and optimizing for cumulative rewards. It is widely used and various applications for from robotics to finance and involves key concepts such as policies, values, function, and exploitation trade-off. Okay, so let's come to the very important topic now. See, we will do some example of this reinforcement also. Okay, so if you people remember, first before I starting this, first I talk about the supervised learning, right? And supervised learning. Now it's time to do the some. Just let me show. In supervised learning, we have some. Yes, we had some. You can say regression and classification algorithms, right? So let's talk about the linear today. Then we'll do decision support vector, ridge regression, and then we'll do the classification problem like decision tree, support vector machine, k nearest, logistic regression, all of this, right? So let's cover each of them one by one. Then we'll proceed to the unsupervised learning. Then we'll come to the reinforcement. In data science, how we can use the linear regression. Okay, just give me 1 minute. Okay, once I explain you this, what we will do, I will give you a real data. Okay, so I will ask you to do some real world implementation also. So must be alert here. Okay, so what is regression analysis in data science? So regression analysis is a powerful statistical method used to examine relationship between variables. It allows us to model and analyze the relationship between a dependent variable, often called a target or output. So it's all about independent and dependent variable. What is the meaning of that? I will tell you. Uh, in data science, regression is widely used for predictive modeling. See, prediction, if we have to give some prediction, we'll use this regression like trend forecasting and understanding relation between the variable. So types of regression in data science. So we have linear regression, and at the bottom we have multiple linear regression, this one, and then we have logistic regression. Okay, all of it. Yes. So let's do the linear regression first, the simple linear regression. So you can see here. Okay, so linear regression. Okay, so models the relationship between two variables fitting a straight line. So you all know that this is very easy one. We just make you know a simple linear regression model. So if you have one independent, one dependent variable, you can use it. So suppose, for example, if according to the weight, if you have to predict the height, then we can use it, right? But in most of the cases, what happens, we have one independent, but we have many dependent. Okay. So, but right now we are having one independent here, which is this one, and one dependent. It's a simple linear regression. So you can see that this is the equation. Sometimes we call it m plus mx plus c. Y is equals to mx plus c, where m is they are calling beta 1, which is slope. X is what? Independent variable. And your C is error terms. Basically, we call it intercept. Intercept. Like for example, if I make a line here, suppose this line, right? So what is M here? M is a slope. Slope means how much this line will rotate. That will be dependent upon the M, right? The rotation of this line is according to the M, and X is the, we can say, its quantity that how much it will rotate. So for example, if it is 1, okay, it will show some behavior like this, which is this one right now. So if it is 1, it will show like this. If you make it 2, might be your line will look like this. It is 2. If your x is -1, your line can be seen like this, right? So this is the mx. And what is c here? C is the distance between origin and this line. So can we repeat again? Suppose this is a line. Tell me what is the M, X, and C here. What is this? Phi. Yeah. Can you anticipate what is M, X? What is M for this line? Yeah, it is slope. You can say you can take any value, but X here is -1. That's why it's making it, rotate in very negative direction. And intercept is the difference from origin to this one. So it is 5, right? So any line will be having these two terms. We can say slope and intercept. Okay. So you can place your line anywhere. You can place it here. You can place it here or here. It just depends upon the slope and your intercept, right? So these two factors will decide where your line is. Okay, okay. So next is let's do a problem over here. Basically, it is one x and one y problem. So we can say one dependent and one independent problem. So let's go through an example how to implement linear regression in Python using a real data set. We will use scikit-learn library. Okay. Predicting house price, right? On the x-axis, you have the size of the house like 1400 square feet, 1600, 1700. So we'll use the small data set where the aim is to predict the house price. Okay, the price is also given. So step by step implementation we'll do in Python. So first of all, import our libraries. So we'll use NumPy's matplotlib to make our graph. Okay, now also because we want to, you know, you can say we want to divide our data in two parts. Some is training set, some is testing set. Okay, so from sklearn model selection, sklearn linear model, import linear regression. So for statistical, we will calculation we will use mean square error. So from as matrix, import that. Okay, so now what we will do? Okay, just 1 minute. Let me comment all of this. For 800, 1600, 1700 and all this. So reshape. So first of all, this is x-axis, this is y-axis. Let us print x. Yeah. So basically, like it converted a straight straight array into the column format because they have done reshape. Okay, I've done reshape here, which is you can also achieve it. And then we have the y-axis. See. Okay, let's now split the data into 80% for training, 20% for testing. So test train split, pass your x, y. Test just mention the text size 20%, and it will give you four variables: x train, x test, y train, y test. Instantiate the linear regression and then fit your model, your x-axis, your x train and y train. So y train, this is your target variable. All right. So this is the feature and this is target variable. So train it, and you will see that after training, you can from model you can easily predict, right? So for example, you can say we have four data. Our data is divided into four parts. This is this is x, this is y, and this is trained data. This is testing data. So you will train on these two values, and then you will give this value to predict this one, right? So we are giving this value here, this one, x text, so that we can find out this one, right? Y prediction. So whatever we get is this is your actual one. This is your actual one, and you will receive Y prediction, a new set, which is prediction. Okay, and this is see whatever prediction we got. Okay, so basically it took our data and must have you know made some of the line. You can say it must have made some line. So with the help of our training data, it must have made some line. So perfect good fit. What slope it got, and what is the we can say what is the coefficient, what is the x we got. So these two things are very important. So let us see. Let me run this one. We are more interested in the this slope, and we can say the coefficient, right? intercept you got, and you got coefficient. You can make your own equation, put your value of x test, and you can find y test, y prediction. मीन स्क्वायर्ड एरर की भी बाद में बात करेंगे. लेट मी प्रिंट, लेट मी विजुलाइज. देखो ये लाइन प्रिडिक्ट हुई है हमारी. So first of all, this is our x, y. We have in the scatter plot view, blue color, and we are also predicting the line which we got, which is a good fit, right? तो वहाँ पे x put किया, and y will be according to our. अब x डालते जाओगे, you will keep on getting the y. So that is in the red color. This is our prediction line. ठीक है, इक्वेशन कैसे बनेगी इसकी? एम एक्स प्लस सी होता है, दैट्स वाई, राइट. उससे हमारा वाई डिसाइड होता है. तो हमारा एम कितना है यहाँ पे? व्हाट इज द एम हेयर? इन दोनों में से एम, टेल मी. 0.12, हाँ करेक्ट. 0.12 इज योर एम, करेक्ट. 0.12 इज योर एम. एंड एक्स आप डालोगे यहाँ पे, और आपका सी आ गया. सी इज द 51.1. ठीक है, तो यू पुट योर एक्स हेयर, लाइक एक्स कुछ भी हो सकता है. फॉर एग्जांपल एक्स आपका 1400, 1600. तो आप डालोगे तो इट विल जस्ट गिव द वाई विच इज द प्राइस. तो आप ग्राफ में भी देख सकते हो यहाँ पे कि अ लिटिल बिट ऑफ इंटरसेप्ट इज हेयर, विच इज, या हेयर यू कैन सी 51 का इंटरसेप्ट है. ठीक है. दिस दिस स्लोप इज, यू कैन सी 0.12. यस. So output mean squared error. This is a metric, gives an idea of how well the model is performing. Lower value indicates better performance. So let's talk about the mean square error. So it was giving mean square error 4973. So that is like हम लोग क्या कहते हैं कि in a graph mean square error how to find out. This is your prediction line. This is your, you can say, the actual line. Sum is the actual lines, right? तो इन दोनों के बीच का डिफरेंस, द योर प्रिडिक्शन एंड द एक्चुअल पॉइंट, इन सबको सम अप करना, ठीक है, जितनी भी लाइन बनेगी हमारी, दीज आर कॉल्ड मीन स्क्वायर्ड एरर. So these are basically called errors, right? तो इन सब का मीन करना सबसे पहले, इन सब का मीन निकालना कितना मीन, और फिर उसके बाद उस मीन का स्क्वायर करना. बिकॉज कुछ नेगेटिव साइड पे होते हैं आपके, कुछ पॉजिटिव साइड पे होते हैं, दोनों एक दूसरे को कैंसिल आउट ना कर जाएं, इसलिए भी ट्राई टू डू स्क्वायर. ठीक है, क्योंकि आप कह सकते हो कि आपके पास 2 है यहाँ पे प्लस 2 है, तो उसका स्क्वायर करोगे 4 आ जाएगा, राइट. अगर आपके पास -2 है, अगर -2 आप डायरेक्टली इसमें जोड़ दोगे तो मे बी इट विल कैंसिल आउट दिस, तो दैट्स वाई वी डू स्क्वायर ऑफ दिस, तो इट विल बिकम 4 अगेन. अभी आप इसमें ज्वाइन करोगे तो इट विल बी लाइक, यस, वी आर एक्चुअली, बाद में लाइक वी कैन डू हाफ ऑफ इट, ठीक है, बट वी गेट द एक्चुअल क्वांटिटी ऑफ इट. तो दिस इज कॉल्ड मीन स्क्वायर्ड एरर. तो बेसिकली क्या होता है कि वी नीड मिनिमम मिनिमम these lines, right? That is called mean square error. तो minimum आपका ये आया है 4900. This is the sum from all of the points and prediction line. तो इसको भी मिनिमाइज करने का एक हमारे पास पूरा एल्गोरिथम है, दैट इज stochastic gradient descent. Intercept we have talked about, coefficient we have talked about, explanation I've given, and okay. I'm giving one data to you, okay. You people just use this linear regression model and try to predict the dependent variable, okay. Basically all the data is having, we can say all the data is having at least a lot of dependent variables. Why? independent variable, sorry, which decide. So do one thing, you can take your dummy data, okay? You can take your dummy data and try to make this model, this one, and also visualize it. All right. So this is the homework, and stochastic gradient descent, multiple linear regression, all this we will do in the next session. All right. Anybody having doubt, they can ask me. Stochastic also we will do with the animation, proper animation tomorrow. And tomorrow I will give you real data on the multiple because in multiple linear regression we have a lot of, where is the data random. You can do one thing, random data, like, okay, I'm giving you random data module use करके, okay, I'm giving you this data, take this data. ऐसा करोगे भी, we have very less shortage of data, which is यही वाला ले लो आप. Okay, have a good day. Tomorrow we'll continue. Okay, have a good day. Bye bye. See you soon. Welcome.